Rainfall data is one of the most critical inputs in hydrology and water resources design, but it's also one of the most misused. In this video, I'll show you how I download rainfall data from TRMM, what is suitable for, and most importantly, how I validate it before using it in engineering design. TRMM stands for Tropical Rainfall Measuring Mission. It's a NASA satellite product designed to estimate rainfall in tropical and subtropical regions. However, TRMM does not measure rainfall at the ground. It estimates rainfall from space, which means it comes with uncertainty and bias. Because of this, I never treat TRMM as ground truth. So how do I download TRMM data? For most projects, I download TRMM data through NASA Giovanni. Let me walk you through it. So you just come to Google and look for Giovanna NASA, click on it. Once it's open, you make sure you just have to log in. If you're using it for the first time, you just have to sign in. Since you have used it before, you're just going to log in. So this is the interface. The first thing you do is select your region, that is your location. So you just come, click here, just have to zoom into your location. Zoom into your desired study area. So once you zoom into your study area, just come and click this icon and then draw a boundary around your study area, just like that, and close. So you already selected your location. Now select the data range from here, let's say from 2000 up to 2019 December 31st. Come and under these pins, you come and check on hydrology, then come under measurements, look for your rainfall data. Rainfall data is under precipitation. Click on precipitation, it's going to process. Once this is processed, you look for precipitation data you want. Let's say you're going to take it in millimeters per day. So come and check on this. After checking here, you come here, make sure at least you put in time series. I'm going to select time series area average. This is majorly just to help you, to give you other options while you're exporting the data, that the file formats you can use for saving your work. Come and plot. So as it's processing, I want to summarize the key things that you follow when you're downloading your data from TRMM. Just the first thing is select your location. After selecting your location, you make sure you select the time period. Selecting the time period for your data, then you come and select your resolution format. Maybe you want it in daily, monthly, annually. Select in that format. Actually, it will bring something like this. Once it brings something like this, come and just click on download. So it's plotting all the time series for the precipitation from the start up to the end date. That is from 2000. That is from 2000 up to 2029. Just come and download, and from here we see our file is in CSV. I'm going to save it in CSV. Click and open and check it out. It's all well from 2000 up to 2019. I normally keep this step simple because downloading data is not where engineering judgment happens. So why is data validation mandatory? The biggest mistake engineers make is usually using satellite rainfall data directly in design calculations. This is very wrong and should always be avoided. When this data is not validated, just know the rainfall error is going to propagate into runoff, flood peaks, spillway size, and ultimate structural safety. So data validation is always mandatory. This is how I validate my rainfall data. The first step is to compare with gauge data. So where get data exists within their project area, I compare long-term totals and seasonal patterns. I make sure I get the mean annual rainfall, the monthly distribution or the wet and dry season timing. This normally helps me for comparison purpose. The second thing I do is just to make sure I cross-check with CHIRPS. I also use CHIRPS rainfall data as an independent satellite product. Now, when two independent data sets agree reasonably, confidence increases. So make sure you take note of that. While we do this, it's even better to do, at least you have the station gauge data, the TRMM data, and then the CHIRPS data. So from here, you can even do some correlation analysis or check for the bias, and then see how to do correction on that bias before using it for your design. Lastly, sometimes I also use double mass curve correction. I normally apply double mass curve analysis to check consistency over time. And you don't need math here, just concept. It is just basically the cumulative TRMM versus cumulative gauge. So if the slope changes, it means there's inconsistency. And then you see how to address it by capturing the different slopes before and after the change. And this step helps me detect bias before it enters the design. This data really helps to connect data to real engineering outcomes. So once validated, TRM data inform decisions such as catchment runoff estimation, design storm selection, spillway capacity, safety factors. So as you know, rainfall data does not design structures. Engineers do. So even after validation, I apply conservative judgment. I make sure I take care of factor of safety. I do some sensitivity checks on the data which has been corrected, and also perform detailed design review. This is really very important because data supports decisions. It does not replace responsibility. And as an engineer, my responsibility is to make sure I do detailed design review for data reliability and ensure safety throughout the project. So TRMM rainfall data is a powerful tool, especially in regions with limited ground stations, but must be used carefully, validated properly, and interpreted with engineering judgment.